Hello, good afternoon, students. So today, just want to continue with talking about the part two of the lesson of Pre-Cal Honors, Chapter 1 and 2. So again, this one, we just try to break it apart into Part 1, Part 2, Part 3. Okay, so it's a lot of content involved right here. So again, Chapter 1 and 2 in Pre-Cal. So pretty much just like review for a lot of Algebra 2 and Geometry and Algebra 2 contents. Okay, so we'll continue to look through the rest of the problem here. Okay, so number 6. So this one is about solving the inequality, absolute value inequality. So anytime they see the structure as absolute value of ax plus b is less than or equal to c or less than c, so therefore it's and. And that means it's considered intersection. Intersection, that means you'll find out the solution that it's going to be overlapping. So the other one is union. If you see anything that's considered greater than or less than, so that means it's or. It's union. So union, that means once you find out the solution is either less than or greater than equal to. Okay. So again, intersections, that means you'll find out things that it's considered overlapping. And then union, that means you'll find out the solution that it's going to two different directions. So less than or less than equal to, and also greater than or equal to or greater than. Okay, so you see that in a minute. And let's look at that, the first one. So A, so absolute value of 2x plus 6 minus 14, it's less than or equal to negative 6. So the way to solve for this. So first thing that you want to do, you want to isolate the absolute value. So take that negative 14 to the right hand side. So we got negative 6 plus 14, which is what? 8. And then from here, you want to break it apart, positive, negative. So for the positive, we just want to keep the exact same inequality. So it's 2x plus 6. It's less than or equals 8. And then for the negative, so that means, well, the inequality, the absolute value, we still want to keep the exact same content. But this time, we need to switch the less than equal to greater than or equal to. And then also the constant, 8, we need to switch that to its opposite. And then from here, you want to solve for x. We do know that's less than or equal to. So less than or equal to, that means it's going to be overlapping. So it's going to be intersection. So you see that in a minute. So 2x is less than a minus 6, which is 2. So x is less than or equal to 1. And then over here, similar. So subtract 6 on both sides. So 2x is greater than or equal to negative 14. And then x, it's greater than or equal to negative 7. And for those you might be wondering, how come you don't switch the sign here? Well, because I'm not dividing by a negative number. It's just positive 2. Okay, so once you sketch the graph for that one, so x is greater than or equal to negative 7. And then x is less than or equal to 1. So that means eventually they're going to be overlapping. Now, what about for the inequality, such as with the rational functions? The rational expressions. So to look at that for B. So let me just snip this one and put it to the new slide. So for the rational inequality, you got to be really careful the way that you set up the 0 and doing the sign test. So kind of like one of the problems we did earlier with the domain, all that. Okay, so let me put it into the new slide for this one. Okay. So for this one, we do have 2 over x minus 3. It's less than x over x minus 2. So basically what we need to do first, we want to bring everything all together to one side. So for those you might be wondering, wait a minute, can we cross multiply? If you try to cross multiply, there's no more denominator. If there's no more denominator, that means we're going to be getting away from the restriction. So you don't want to deal with that cross multiplying because that it's considered rational. Okay, so rational expression, inequality. So please, you don't want to do cross multiplying. Okay, so no cross multiplying. Well, because that once you do cross multiplying, what happened? So you see that the denominators all cancel. There's no more denominator, and that means we're getting away from the restriction. So set that equal to 0, bring everything together. So similar to what you did in algebra 2, so it's combine the rational expression together, subtraction. So that means this time we need to find the least common denominator. So it's x minus 3, x minus 2, and the other one similar, well, it's the same thing, x minus 3, x minus 2. So multiply the missing element, top and the bottom, so multiply by x minus 2, right here on the top. And then over here, multiply by x minus 3. So make sure that you carry the x over. Okay, so this one. And then since we do have the exact same denominator, so that means, so we can just bring all this together. So put this all together. So what we got here is 2x minus 4 minus x squared minus negative negative positive plus 3x. So as you can see that the top is going to be considered a quadratic trinomial. So simplify the whole thing. We do have negative x squared, and then 3x, 2x, 5x, and then minus 4. And for those you might be wondering, can we factor this? Yeah, multiply both sides by negative 1, so just swap the sign. So we got x squared plus 5 minus 5x. Okay, so let me fix that. Minus 5x, and then plus 4. So simply multiply both sides by negative 1. Again, denominator, just leave it as x minus 3, x minus 2. You'll see that we'll be using that for in a minute. So it's about the restriction. So the top part right here, we try to factor it. So what we got, it's x minus 4, x minus 1. And then the denominator, again, still keep that x minus 3, x minus 2. So now you might be wondering the zeros on the top. So we do have x equals 4, x equals 1. And then what about the denominator? If we try to find the vertical asymptote, so x cannot be 3, so x equals 3, and x is what? 2. So for those you might be wondering, why do I need to put in all this? Well, because this one would be the restriction, the restrictive value, or the extraneous solution. Because this one we need to satisfy the inequality. So whatever the result that we have, it's always less than 0. So again, we want to do the sign test. So try to arrange the number from the least to the greatest with all the impossible zeros. So we got 1, 2, 3, and 4. Again, this one, it goes all the way from negative infinity to infinity. So the factor that we have is what? X minus 4, x minus 1, x minus 3, x minus 2, and then the final result. So try to test the sign change here. So anything that's from negative infinity to 1, so that means we want to put in 0. So 0 minus 4, negative. 0 minus 1, negative. 0 minus 3, negative. 0 minus 2, negative. So it's all 4 negative. Negative times negative times negative times negative, positive. So that's the result. Is that what we want? Oh, you know what? One thing I forgot to do here. This one's supposed to be greater than. Because once you multiply by negative on both sides, so we need to switch the less than to its greater than. So that's the error. But now let's fix it. Greater than. So eventually we need to have something greater than 0. So positive, it is greater than 0. So that's the result we want. Okay, so yes. And then what about the one right between 1 and 2? So let's say 1.5, excuse me. So plug in 1.5. So we do have negative, positive, negative, 1.5 minus 2, negative. So negative times positive times negative, which is negative. So that's not the result, so no. So again, the first one is yes. And then in between 2 and 3, so 2.5 or 2.5. So 2.5 minus 4, negative. 2.5 minus 1, positive. 2.5 minus 3, negative. 2.5 minus 2, positive. So is that the result we want? Yes. Because negative times negative, positive, times the rest of the positive is still positive, yes. And what about anything that's greater than 3 but less than 4 in the interval? So right here, 3.5. So 3.5 minus 4, negative. 3.5 minus 1, positive. 3.5 minus 3, positive. 3.5 minus 2, positive. So it's negative result. That's not what we want. again, we need to have something greater than 0. And what about anything that's greater than 3.5, greater than 4? So 5. So 5 minus 4 positive, 5 minus 1 positive, 5 minus 3 positive, 5 minus 2 positive. So it's all positive here. Yes. So we got yes, yes, yes. So that means we do have 3 interval notations for this domain, or for this inequality. So by the time that you solve for x, you can say that x, it's right between negative infinity to 1. Okay, so negative infinity to 1. And what else? In between 2 and 3. In between 2 and 3. So this one's a union. And union, what else? 4 to infinity. So on those intervals, you'll find out all the solution there. Okay? So for the no interval, it's not part of the inequality solution. Okay, so now let's see what else that we have going back to the template. So what about for the absolute value with the quadratic, and then it's considered greater than or equals 6? Okay, so we'll take a look at that one. And for D, it's quite similar to what we have for B. Okay, so let's take a look at that for C. It's absolute value, quadratic, inequality. So again, anytime that you deal with the nonlinear inequality, so that means we have to do the sign tests with the chart like this, okay? So you need to find out all the impossible 0 or the possible zeros, and then find out that the interval in between. Okay, so now here's another one, but this time it's an absolute value, quadratic inequality. So first thing that you want to do, well, obviously you want to factor it, okay? So try to factor this. Okay, so let's see what we can come up with that. So factor, we do have x plus 2, and then x plus 1. Its absolute value, which is greater than or equals positive 6. If you try to undo the absolute value, well, before you undo it, you can always separate it out. Okay, so try to separate it out. So this one would be considered absolute value of x plus 2 times absolute value of x plus 1. It's greater than or equals 6. So you might be wondering, 6, can we break it apart into 2 and 3? You know, all that. But you don't want to deal with things like, you know, factor form. And now the things that you can do. You can always bring the 6 to the left-hand side. So we can set the other side equals 0. Because this one is nonlinear, quadratic. So another way that you can deal with this, so instead of factoring it, so we can always take that plus minus the quantity of x squared plus 3x plus 2, and then minus 6. And then set it greater than or equals 0. Again, it's nonlinear, quadratic. So this one, we just want to bring everything together. So as you can see that we do have positive, negative. So we do have 2 different outcome here. So start with the positive. So for the positive, we do have x squared plus 3x plus 2 minus 6. So 2 minus 6, then that'll be negative 4. Again, greater than or equals 0. And then for the negative, then that would be considered negative x squared plus 3x minus 3x, excuse me, because the sign you want to distribute. Minus 2, and then minus 6. It's greater than or equals 0. Well, this time it's negative, so it's what? It's less than or equals 0. Okay, so you'll see that in a minute. And now for those you might be wondering, greater than or equal to, so inequality, would that be considered all real solutions or just no solution? Well, we'll find out. Okay, so again, negative, so we swap the sign. And then for this one, so try to factor it. So what we got, it's x plus 4, x minus 1, greater than or equal 0. And then this one here, combine the like terms. So negative x squared minus 3x minus 8. And then you might be wondering, what is it? Less than or equal 0. And it looks like this part right here, it's non-factorable. So in order to deal with the negative, so multiply negative on both sides. So we got x squared plus 3x plus 8. It's greater than or equal 0. So again, multiply everything by negative 1. So non-factorable, that means we have to apply the quadratic formula to find out the possible 0. So let's start it with this part first. Again, inequality. So we got 1, well, negative 4 for the possible 0. And then 1. And then this one, negative infinity to infinity. So we just want to find out the sign. So make sure that is satisfied with the result. So again, eventually we need to end up with something that's greater than or equal 0. So the factor we have here, so x plus 4, x minus 1, and then the result. So number right between negative infinity to negative 4, negative 5. Number right between negative 4 and 1, 0. Number that's greater than 1, 2. So negative 5 plus 4, that's negative. Negative 5 minus 1, negative. Negative times negative, positive. Is that the result we want? Greater than 0? Yes. And what about plugging 0? So 0 plus 4, positive. 0 minus 1, negative. Positive times negative, negative. Well, obviously that's not the result we want. And then what about anything greater than 1? So for 2, so 2 plus 4, 6, positive. 2 minus 1, positive. And then positive result, yes, that's what we want. So part of the interval solution here, so it's from negative infinity to negative 4. And then union right here, and then 1 to infinity. Now, but what about this? Well, this one you want to use the quadratic formula to find out the possible 0 first. So x equals negative b, negative 3 plus minus, square root of 9 minus 4ac. So 4 times 1 times 8. So 9 minus 32. So negative 3 plus minus. So 9 minus 32, which is negative 23. All over 2. So this one will give you negative 3 over 2 plus minus root 23 over 2i. So this one's going to be in the complex number field. So there's no need to worry about that, the complex number field, because that's a negative imaginary number. So that means the real solution will be going from negative infinity to negative 4, and then 1 to infinity. Okay, so now let's see what else that we have for another problem like this. Okay, so again, if you see the absolute value, so that means you need to undo the absolute value. So making sure that it's positive and negative. So we do have two possible inequality. Okay, so the rest of this is for the practice. And for this one here, so this one is kind of interesting for number 6. So solve each inequality. So absolute value of x plus absolute value of x minus y equals 2. So you want to sketch the graph for this. We're not solving it. So try to do on decimal here. So you'll see that it's considered a parallelogram. Okay? Well, why is a parallelogram? Because once you try to undo the absolute value, you'll see that there are 4 possibilities. Okay, so that's what I'm going to show you in a minute. So 4 different possibilities. Okay, so first part of it, it's considered plus minus x. And then undo the absolute value for this one. So that would be plus minus the quantity of x minus y. So that equals 2. So you started with a positive. So we do have 2x minus y equals 2. So in other words, y equals 2x minus 2. So that's the first possibility. So what about negative? So for negative, so we do have negative x minus the quantity of x minus y equals 2. So negative 2x plus y equals 2. So that means y equals 2x plus 2. Okay, so that's the second possibility. And what about the third and the fourth? The third possibility is that negative x, positive quantity x minus y. So the third possibility, negative x plus x minus y, so equals 2. And you may notice that negative x, positive x got cancelled. What's left? Negative y equals 2. So in other words, y equals negative 2. Okay, so 1, 2, and 3 possible equation. They're all linear function. They're all considered a straight line. And then what about the fourth possibility? Is that consider positive x and negative quantity of x minus y. So positive x, negative quantity of x minus y. So this time, once again, x got canceled. Negative, negative, y, positive y. Y equals -2. So it's 4 different possibilities. So flat line, this one's slanted. So once you construct them, what do you notice? It's all considered a parallelogram. And once you extend it, you'll see that the point where they intersect. So extend the line, y equals 2, y equals -2, and the other one here, so y equals 2x minus 2, and then over here, y equals 2x plus 2. So that's why it's a parallelogram. So it's kind of interesting, right? And then the other one, so if you see the absolute value, so this one's similar. So instead of using the decimal or TI-84, so undo the absolute value. So we do have f of x equals x plus 1. Well, you can always swap the terms. It's addition, commutative properties of addition. And then undo the absolute value plus minus the quantity of x plus 1. And you may notice that reduce, what's left here, plus minus 1. So this one is a piecewise function. So piecewise function, so that means f of x equals 1 for anything that x is greater than -1. Because once you set up x is greater than -1, so it's all positive. And then x is less than -1, and then the function would be considered -1. And now you might be wondering, why is that? Well, because that's the restriction. You see that right here? It's irrational. What happens if you plug in -1? It's going to be considered 0. That means the whole thing would be undefined. So this one is being shifted 1 unit to the left. It's positive 1. So that means h is what? -1. So 1 unit shifted to the left. And then right up here, open circle at 1. Going all the way to the right. And then down here, open circle, it's going all the way to the left. If you try to verify that on decimal, it's going to show you the exact same graph. And this one, you probably want to do that on the decimal, because that's going to show like 1, 2, 3, 4 part of the piecewise function. Okay? Because once you do the absolute value, plus minus the quantity of x plus 1, minus 2 times the quantity of plus minus x minus 2. So it's going to be 4 different part of the piecewise functions. So try to do this one on decimal. So you see that, the piecewise function graph. And let's see what else that we have for the rest of this. So find the value of x that satisfies each inequality, and then give the graph which intersect at 0, 0. Okay, we do know that 0, 0. That's the first point where they intersect, f of x, g of x. And the other one is 3, 3. Another point where that we can find the common position. So for f of x is less than or equal to g of x. So f of x. So f of x is less than g of x. So that means it's somewhere right over here, -infinity to 0. Okay, so -infinity to 0. Union, what else? What about this part of the graph? F of x is also showing that it's less than or equal to g of x. So 3 to infinity. So g of x is greater than 0, so g of x is greater than 0. So that means anything that it's right above the line, it's right above the x-axis. So from 0 to infinity. F of x is less than or equals 0. So f of x is less than or equals 0. So anything from -infinity to 0. Union, again, the curve is f of x. So 4 to infinity. And the other one showing g of x is greater than f of x. So g of x is greater than f of x. So that means the line, it's right on top of the curve. It's right above. So the one that's happening there, g of x is greater than f of x. Then that would be -infinity. Oh, you know what? The first one, I think I messed up with the first one for A. So the first one is showing that f of x is less than g of x. Well, that's right. It's the same thing. Okay, so less than, that's right. And g of x is greater than f of x, then that would be from negative infinity to 0. And then union. Okay, so 3 to infinity. But for the first one, it's also equal to, so that means at 0, it's a closed bracket here. It's included. And also at 3, it's also included. And then what about the one that's ran between 0 and 4 for f of x? Ran between 0 and 4. So right over here. So from 0 to 4. Again, the function from 0 to 4, the boundary. So that happens right between 0 and 4. So what a coincidence. It's the same as the domain. Okay, so for the rest of this, we'll look at that for the next part of the video. Okay, so the rest of this is about transformation. We'll get to that. And also we'll talk about the way to describe the transformation. And also inverses, the way to find the inverse function. All that. Okay, so stay tuned. So we'll be doing things like that for the other part of the video. Okay, I'll see you guys next time. Have a great one.